three charges. Q1, Q2, Q3, there they are. There's numbers. Lie along the x-axis at 0, 0.03, and 0.05 respectively. That just means that 1 is at 0, 2 is at 3, 0.03, and 3 is at 0.05. That's all respectively means. Okay? Calculate the electric force, magnitude, and direction on Q3. Notice, okay? Inhale, exhale, repeat. I'm not making you do all three of them. Just making you do one.
You try and make it sound like that's better.
It is better.
Is it positive to negative or negative to positive?
You mean the direction?
Yeah, like
The direction of the field?
If you have positive and negative, which way does it go?
From positive to negative. Okay, so 3 charges. There they are. So first things first is you want to draw a diagram. A very simple diagram, but it's really going to help with the direction. And yes, you need to be able to do the direction. So we got Q1 here at a position of 0.0. We got Q2 here at a position of 0.03. And we've got Q3 here at a position of 0.05. And then the values for these are positive 3.2 times 10 to the negative 6, positive 5.0 times 10 to the negative 6, positive 2.9 times 10 to the negative 6. Yep.
Okay, dumb question. Are those periods or commas? Because, like, 0, 0 could be an XY, but it also could be a decimal.
Oh, you're talking about this?
Yeah.
These are decimals.
Decimal? Okay.
Yeah. Yeah, they're not coordinate points.
Okay.
Okay. Now, first things first. Well, we already did first things first. Second things second. We need to find the force acting on Q3. And the way we do this is called superposition, which is literally what the last video was about. It means adding things on top of each other. Okay? So superposition for quantum mechanics is things can act as waves and particles, which means they can have more than one state at a time. This is more than one force at a time. So what are the forces? Well, there's a force acting between 2 and 3. That's the obvious one. But there's also a force acting between 1 and 3. And that one's not quite as obvious. But should be on the equation sheet. Through 9 times 10 to the 9th. Good. I didn't want to say the wrong thing, but that's what I thought. Okay, so how do we add the forces on Q3? We find the two forces on Q3. So the first force is the force between 2 and 3. And we add that to the second force, was the force between 1 and 3. Okay? So far, so good. Once we've got that part, then we need to find these actual values. So we need to find what F, Q2, Q3 is. Q23, however you want to write it. So the equation is F equals K Q1 Q2 over D squared. So K is on the equation sheet. It's 9 times 10 to the 9th. Q1 is the first charge, which the first charge is Q2, which is 5 times 10 to the negative 6. Q2 is 2.9 times 10 to the negative 6. Well, Q2 is RQ3. And the distance between them is 0.03 to 0.05, which is 0.02. squared. Okay, here's what I want y'all to do. I want y'all to solve this. Solve for Q2, Q3, and see what you get. Then you'll need to also set up the force between 3 and 1. And get an answer. Once you have those two numbers, then you can plug them in here and solve for Q3. Okay? I want you to try it on your own here first. I'm going to give you a little bit of time to do that. And then we'll talk about it again here. Okay, so once you get the set up, you'll go ahead and plug it in and solve. So 9 to the 9th times 5 to the negative 6 times 2.9 to the negative 6 divided by 0.02 squared. That gives me That gives me 326.25. I saw a lot of people get 32.6. My guess is you did 0.2 instead of 0.02. That's my guess. But just be careful on the values that you do. Okay? The setup will be the same for 1 and 3. But you're going to change this to 3.2 to the negative 6. This will stay 5. Or sorry, this will stay 2.9 to the negative 6. Anyway, they're going to both be positive because they're going to both push this one to the right to repel it. Anyway, have a great weekend, y'all. Okay, skipping ahead a little bit, we've solved Q1, Q3, and Q2, Q3. So the force between 2 and 3 is 326.25 newtons, and the force between 1 and 3 is 33.4 newtons. So all we need to do now is add these together here. What's happening? Is it? Okay, now that we've got the forces found, we need to plug them in and solve for Q3. So Q3 is a combination of the force acting between 2 and 3 and the force between 1 and 3. We found the force between 2 and 3 to be 326.25. And we found the force between 1 and 3 to be 33.4. What we need to do now is figure out the direction. And here's how you do it. You look at the charge that you're interested in. We're interested in Q3. And you ask yourself, what direction will Q3 move because of Q2? So Q3 is positive. Q2 is positive. So they're going to repel. So which direction will it repel? It will repel to the right because of Q2. So this would be a positive force between 2 and 3. So then I look at 1 and 3. Okay, what direction will 3 move because of 1? So 3 is positive, 1 is positive, light charges repel. It'll be repelled away from Q1, which will go to the right in this case. So this will also be plus. So all we need to do is add those two numbers together, 33.4 to 326.25, and we get Q3 to be 359.6 newtons. Okay, this would obviously change if I was looking for Q2. If I was looking for Q2, Q2 will be repelled to the right from Q1, but it'll be repelled to the left by Q3. If I made one of these negative instead of positive, that would also change. So there's a lot of places where that can change, but that's the basic idea of how to solve the problem.